Higher order derivatives. On page 182, exercise 36, y equals 2x plus 3 over 5x minus 1. Y prime is the derivative. The derivative of a quotient is the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over the denominator squared. Distributing the 2, we get 10x minus 2. Here we distribute the negative and also the 5. Negative 5 times 2x is negative 10x. And negative 5 times positive 3 is negative 15. All over 5x minus 1 squared. That's just distributing. Be careful with this sign. It distributes, but so does the 5. So y prime equals negative 17 over 5x minus 1 quantity squared. That's combining like terms. Y prime could also be symbolized the derivative of y with respect to x. The directions are to find y double prime. This is called the second derivative. It means the derivative of the derivative. It's symbolized y double prime or d with a 2 superscript, y over d x with the 2 subscript on the x. It means 2 superscript. Both of these symbols mean the second derivative. The derivative of this can be found with the quotient rule, or by first rewriting this as this number, negative 17, times 5x minus 1 raised to the negative 2. These are equivalent, this and this. So instead of using the quotient rule, which we could, we're going to use the rule called the chain rule, where there's 4 things to do. The first thing is multiply the exponent by this number out here. The second thing is to copy the 5x minus 1, copying whatever's in the parentheses. The third thing is to make the exponent go down by 1. Negative 2 minus 1 is negative 3. That's the third thing. And the last thing is multiply by the derivative of what is in the parentheses. These 4 things we call the chain rule or the power rule. Multiply, copy, subtract 1, and multiply by the derivative of what's inside the parentheses. So the second derivative of the original function is 34 times 5, which is 170, times 5x minus 1 raised to the negative 3, which could also be written as 170 over 5x minus 1 raised to the positive 3. Exercise 48. S of t, s is a function of t. It equals t squared minus 1/2 t plus 3. When s is something that's measured in meters, which it says, and t is something measured in seconds, something measured in meters is often called distance, or sometimes we call it the position. T is measured in seconds, of course we call that time. When we find the derivative of s with respect to t, we get something that would be measured in meters per second, and we call that velocity. V for velocity. And when we find the derivative of the velocity with respect to time, we get something that would be measured in meters per second. That's this letter. Per second. It's down there is time, which is second. Often written meters per second squared. And that is what we call acceleration. So in this exercise, S of t is t squared minus 1/2 t plus 3. Part A says find v of t. That means the derivative of s, which is measured in meters, with respect to time, which is measured in seconds. And that's 2t minus 1/2. Part B says find the acceleration a of t. That means the derivative of the velocity with respect to t, time. And this is the velocity. The derivative of the velocity with respect to t is 2, because it's the derivative of 2t is 2, and the derivative of a constant is 0. Part C says find the velocity, that's the symbol, when t is 1, and the acceleration, that's the symbol for acceleration, when t is 1. So we go back up here for the velocity when t is 1 is 2 times 1 minus 1/2. Which is 1/2. And we're going to label that because of the definition of velocity. Right here, we know the label is meters per second. And the acceleration in this exercise is a constant. That means there's no t in this. That means the acceleration is always this. The acceleration when t is 1 is 2. Because it doesn't matter what t is in this exercise. And because the definition of acceleration is right here, this label, the label for this answer is meters per second per second. Before we do the next exercise, the following are important facts. When the derivative of a function, I'll call that f prime, is positive, then the function is increasing. When the derivative of a function is negative, then the function is decreasing. When the derivative of a function is 0, that means the function has a horizontal tangent line. wherever the derivative is 0. The derivative is the slope. So we're going to do page 212, exercise 16. F of x equals 12 plus 9x minus 3x squared minus x to the third. The derivative of this function, f prime of x, equals 0 plus 9 minus 6x minus 3x squared. There's a 1 here. You can't see. We're going to find when the derivative is equal to 0. To solve this equation, I'm going to divide both sides by -3. Dividing both sides by -3. This becomes a -3. This becomes a positive 2x. And this becomes a positive x squared. If we divide by -3, we have to divide the other side by -3. This equation is now x squared plus 2x minus 3 equals 0, which we can solve by factoring. X plus 3 times x minus 1 equals 0 when x equals -3, or when x equals 1. So now we're going to make a chart with these labels. F, which represents this function right here. F prime represents this right here. And x on this x-axis here, don't make a y-axis anywhere. We're going to mark -3 and indicate that when x is -3, f prime is 0. So we set f prime equal to 0 and found this x. So -3 is the x that makes f prime 0. And 1 also. When x is 1, when x is 1, f prime is 0. Now we're going to substitute any number over here, like -4 for example, into f prime. And when I say plug into f prime, you actually could plug into this. When x is -4, -4 plus 3 will be a negative, and -4 minus 1 is also a negative. And when these are multiplied, a negative times a negative, we get a positive. So we just plugged any number to the left of -3 into f prime, and we see that we get a positive number. Pick any number in this interval from -3 to 1. 0, for example. When x is 0, f prime is 9. Okay, so I think I made a mistake because I have to plug -4 in. You do have to plug it into this. So I made a mistake when I said plug it into that. -4 So actually this comes out negative. Erase this, make it negative. When you plug in 0, f prime is a positive number. When I say 0, I really mean pick any number in between -3 and 1. And then plug in 2. When I say 2, I mean any number bigger than 1. When we plug 2 into the derivative, we get a negative number. F prime means the derivative, which means the slope. Any function with a negative slope is decreasing. Any function with a positive slope is increasing. And any function with a negative slope is decreasing. So from this I can tell, I'll retrace this in red, that f has what we call a relative, sometimes called local instead of relative, minimum when x is this number right here. And the y-coordinate is found by replacing x with -3 in the original equation. This is what y equals. So plug -3 in here, and y comes out to be, do that on a calculator, -15. I also can tell from this, down, up, down, that f has a relative maximum. I'm going to abbreviate these now. When x is this number 1. And the y-coordinate we find by plugging plug 1 into what y equals, the original function. All the x's here make them 1, and y comes out to be 17. We do that on a calculator. And that's that. That's exercise 16. And the graph, if you took the time to make the graph, you would see that it looks like this. This is y equals 12 plus 9x minus 3x squared minus x to the third. It decreases, then increases, then decreases. Where the graph changes from decreasing to increasing, we call a local minimum or relative minimum. And where the function changes from increasing to decreasing, the point where that changes is called a local maximum or a relative maximum. There's one more exercise in this video. It's number 76. It's on page 213. It says g of x has a positive derivative in this interval from -infinity up to -2. And also in this interval from 4 to 7. It says g of x has a negative derivative from -2 up to 4 and from 7 to infinity. These intervals are x values. Intervals that are given are always x intervals. Well, I'm going to record all this information on a chart like in the last exercise. G prime x from -infinity up to -2. G prime, G has a positive derivative. So G prime is the derivative of G. From -2 up to 4, g has a negative derivative in the interval from -2 to 4. From 4 to 7, g has a positive derivative. And from 7 to infinity, g has a negative derivative. This information says that g is increasing, then decreasing, then increasing, then decreasing. This g prime means the slope. When something has a positive slope, if a function has a positive slope, it looks like this. This exercise will have more than one correct answer. It says draw a graph to match the description. So at the point where x is -2, I'm going to just plot some point. The y-coordinate cannot be determined from the information that's given. But I do know that the function that I'm going to graph, called g of x, has to be increasing up to that point. When I say that point, I mean the point where x is -2. And I'm going to go to 4 and plot some point. But it has to be lower than that point because g, which I'm graphing here, has to be decreasing from where x is -2 to where x is 4. And then here's 7. At 7, I'll plot this point, which has to be higher than that point because g is increasing from 4 to 7. It means from where x is 4 to where x is 7. And then after x equals 7, g is decreasing. So this is the point -2 whatever. This is the point 4 whatever. And this is the point 7 whatever. As long as the graph increases up to where x is -2, decreases for the x values between -2 and 4. It's from this blue mark up to this blue mark. Increasing from where x is 4 to where x is 7. That's from this red mark to this red mark. And then increasing after from where x is 7 onward. Decreasing from where x is 7 onward.